Start recording. Okay. Abhinav is there. Today Abhinav has came. Hey Abhinav. हाँ टीचर्स की वैकेंसी चाहिए हाँ. I'll kill you Abhinav. अभी आवाज आ रही है.
यस सर आ रही है. हेलो
हाँ तो तुमको लगेगा मतलब अभी
यस सर.
अपने करना है. पढ़ाई करो पहले.
दिए
हाँ चलो चलो आ जाओ. करते हैं वेलोसिटी टाइम ग्राफ. ओके अभिनव माइक बंद कर लेना. ठीक है. Okay, guys. So, good evening, everyone. Let us do this. Okay. So, till now we have discussed like, let's suppose if I have velocity time graph, and if I draw a curve over here, if it is an increasing curve in the direction of motion, that means what? Accelerating. It is a kind of accelerating. Why? Because if we calculate the slope at these 2 points, what we observe that the right angle triangle made by this slope or right angle triangle made by this slope has one important property. The angle over here is much more greater. Angle at point D is much more greater than angle at point C, and that is also acute. So that means what? First important thing, this slope will be positive since theta is acute. So tan theta D will be much more greater than tan theta C, and that's why velocity acceleration at point D will be much more than acceleration at point C. So this is a kind of non-uniform velocity graph. After that, there is a non-uniform acceleration, means acceleration is not constant, acceleration is also increasing, and velocity time graph is rising upward or not. So this till this we have discussed. Okay, so we need to move to next question. Till now, any kind of doubt is there or not? Means is there any kind of doubt with anyone? No, no. Can you move ahead?
No, sir.
Okay, so moving to next part. Now I'll include acceleration, little bit of different kinds of acceleration for the particle. Okay, so this is the main graph type third. Okay. Now I have an still a increasing graph, means still it is an increasing graph, but try to see at point E and F. Can you predict what this graph is telling? Anyone? Can you tell me like what is the nature of this graph? Means what does this graph is telling?
सर दिस ग्राफ इज showing variable accelerations.
Yeah, variable acceleration is correct. But what kind of variable acceleration? That is the most important point. Okay, to know
The
about that.
acceleration is non-uniform.
That's I got you. I got you, Abhinav. Look over here. So everyone, please try to see this graph perfectly. Okay, so one of the most important thing about this graph is what do we observe that still it is an increasing graph. Means okay, it is increasing up. But when you draw this particular right angle triangle at these points for these like if I want to know what is the nature at point T, I drawn one tangent over here. What is the nature at point F? First I'll draw one tangent. After drawing the tangent, you need to draw a right angle triangle. Okay, I have drawn this right angle triangles over here. What I observe that angle in this triangle, like this theta 1 and this is my theta 2. What I observe that theta 1 is much more greater than theta 2. Second point, that means what? Tan of theta 1 will be much more greater than tan of theta 2. But I know now that this is velocity time graph. Tan theta, like it is in the velocity, let's suppose if I calculate the slope in velocity time graph, we know that slope in VT graph is going to give you acceleration. That's what we know correctly. Okay. Now what we observe, tan theta 1 is what? Nothing but velocity divided by time. So V1 by time t1, and tan theta 2, this is velocity V2 divided by time gap t2. So velocity V2 by time gap t2. Yes or no? So what we observe that acceleration at point E is much more greater than acceleration at point F. And that's correct. If the slope of VT graph at point E is much more as compared to the slope of VT graph at F, then acceleration at E is much more greater than acceleration at F. So can I say that this is a decreasing acceleration graph? What kind of graph it is?
Yes sir.
It is a kind of decreasing acceleration graph. Sneha, Radha, are you able to understand or not?
Yes, sir.
Okay. Sanjana, Arpita, are able to understand perfectly?
Yes, sir.
Okay, so what is happening? What is happening over here at these particular 2 points means at these points, since the slope is very much less. So what is happening? Acceleration at point E is much more greater than acceleration at point F. So it is a kind of decreasing acceleration. Now, if there is a decrease in the acceleration, what is going to happen? Velocity is going to decrease or not? Tell me yes or no. So I can say that it is a decrease in the velocity, decrease in the velocity, and this will be predicted by everyone. Means all of you guys which are sitting over here and all of you guys which are watching on the YouTube, they will say that it is a kind of decreasing acceleration. But actually, what you see the nature of the graph, zero velocity is over here. At t1 some extra velocity, at t2 some extra velocity, at t3 some extra velocity. So here velocity is increasing, but although acceleration is decreasing. How is it possible? Can you say me?
The velocity is increasing, but the rate of change of velocity is decreasing.
So what does this mean? Can you tell me? Can anyone give me one example of this, of a real example based upon this particular graph? Means a real, one of the most, only one example is there, and that is one of the most crucial example. Think about it.
Sir, roller coaster.
Mm-hmm. Roller coaster. Mm, kind of. Who said this? Roller coaster? Haha. No, Iraj or Nissan. A roller coaster. Okay. So what happens with the roller coaster? Have you seen roller coasters? That it increases the velocity. That's one of the best example and correct also. What happens with the I'll take just example of a normal roller coaster. Okay, practical example. Okay, so I think in the younger age you have went to this kind of like let's say this is the path. Oh shit. Okay, so this is a kind of have you seen those boat kind of a structure attached with the hinges over here, and it used to oscillate here and there. So what used to happen? Like try to understand when this particular roller coaster is used to coming, like let's suppose it is coming down over in this side. Okay, what I will observe that when it is coming down in this particular direction, its velocity is increasing. At this point, it will have a V maximum, but also a brake is applied so as to decrease the rate of this velocity so that it can only go up to this point and then return back. It should not go away from this point. Got it or not? So what we do, we throw it under the gravity. Means we throw this particular boat under the gravity so that its maximum velocity increases due to the gravity, but we also decrease it. Why we decrease it? Since that it should not go. Second example is, if you have seen the lift. Have you seen the lifts or not? Tell me yes or no. In lift we keep the persons, yes or no, we keep the person and we try to, like let's suppose this lift is coming down. Let's suppose this lift is coming down. When it will be coming down, what will happen? Its velocity is going to decrease, but one rope will be tied over here so as to decrease the velocity of the lift. Got it or not? So that the lift velocity should decrease at some kind of last point. Understood or not? So these are two basic examples where velocity increases but acceleration decreases. And here we can't say that it is a retardation. This is not a case of retardation, because in retardation, final velocity decreases with respect to the initial velocity. So it is a case of increasing velocity but decreasing the acceleration. So what one most important thing is happening here, increase in the velocity is happening. And most important example is a roller coaster coming down. Hey, who have given this example really? This roller coaster?
Sir, me, Nishant.
Okay, Nishant, I got to know. Coming down. That's great, Nishant. Really, really means it's a nice thing. Okay, so are you able to understand or not? Tell me yes or no. Any kind of doubt till now? Everyone?
No,
No,
sir.
no logical doubt. Sneha, Sujit, Hitesh, Vivek,
No, sir.
Yuvraj? No doubt, na. Sanjana?
No, sir.
Nishant? Okay. Moving to next case. Fourth case. Type 4. And this is, let's suppose, coming to this point. Now, can you tell me what is the nature of this graph? Now, try to tell me about this graph. Okay. So now consider one
Sir,
point.
retardation.
Retardation, yeah, correct. But try to understand, see this. What we observe, that if we found that theta over here, theta is first greater than 90, less than 180. So if theta is, if I take this particular range of theta,
Slope is negative.
yeah, so tan theta at this time is always a negative value. Yes or no? Tan theta is negative at these kind of cases. If tan theta is negative, that means what? Acceleration will be also negative. We know that what is called as negative acceleration, and that is called as retardation. What is called as negative acceleration, guys? It is retardation. So here, what is happening from initial velocity? Try to see it has a maximum initial velocity. It is getting zero over here. Okay, this initial velocity is getting zero. So it is a perfect case of retardation. Next thing, in which direction it is happening? So it is happening along the direction of motion only, along the forward direction of motion. It is happening along the forward direction of motion. When it is happening along the forward direction of motion, one most important thing is also applicable. Try to see that this decrease in velocity, that v by t is always constant. What is happening? Let's suppose if I take 3 points, let's suppose this whole distance is divided with v1 t1, v2 t2, v3 T3, then this decrease, the ratio of decrease, that V3 by T3, V2 by T2, minus of V1 by T1, minus of V1 by T1 is equal to minus of V2 by T2 is equal to minus of V3 by T3. This is what it is showing. That means what? It is a uniformly retarding graph. What kind of graph? Uniformly retarding graph. Got it or not? Yes or no? Are you able to understand this or not? Tell me. Any kind of doubt? Everyone? नो ना युवराज अभिनव निशांत
Understood, sir.
अंकित कोई दिक्कत नहीं संजना राधा नो प्रॉब्लम ना स्नेहा अर्पिता
No, sir.
yeah so
Yeah, sir.
so this is a kind of uniformly retarding graph, means retardation is going to happen in a uniform way. The particular velocity of the graphs will be decreasing with a uniform rate. Okay, next, fourth case, fifth case. Okay, now it comes to another example. Now we know that every retardation, try to see this graph either can go up or either it can go down, and it will give you two different cases of retardation. Yes or no? So here we have first different case of retardation when graph is going down. With the retardation, graph is also going down. Can you explain me? Anyone?
Sir, non-uniform decreasing retardation.
Yeah, non-uniform retardation, correct.
Sir, when the velocity at point T1, T1 G is greater than
Velocity at point Z is greater than velocity at point H.
H.
Yeah, yes or no? Can I say that? Mm-hmm. Hitesh, tell me, Hitesh. Mm-hmm.
Yes, sir.
Can I say that? It is a velocity time graph, Hitesh. Think again.
Sir, acceleration. I told acceleration.
Yeah. So you have to say what is decreasing.
Sir,
What is decreasing? So look over here. Try to understand. One of the most important
sir,
case.
acceleration.
Yeah, but wait, Hitesh. This is where you will get caught. Okay, this is where you will get caught. Okay, so first at point Z, if I want to talk about retardation at point Z or H, I need to draw one right angle triangle over here. I have drawn my right angle triangle. So what is happening? Slope at point Z, slope at G is greater than slope at H. Okay. Now, actually, this is not a perfect slope. This is here minus of theta. If we take, let's suppose if I extend this, wait, if I extend this till here, if I make this a right angle triangle till this bigger right angle triangle, we know we need to calculate the slope using the x-axis. This theta I need to consider. So if I consider this theta, that means what? Tan theta at G is much more less than tan theta at H. Can I write like this or not? Tell me yes or no. Because it is a negative value. What will happen? So in terms of negative value, minus of tan theta at G is much more greater than minus of tan theta at point H. Yes or no? Can I say that or not? Tell me. This value, everyone, minus of tan theta at G is greater than minus of tan theta at H. Can I say that or not?
Yes, sir.
Yes, sir.
Yes or no? Abhinav, Nisant, Radha, Sanjana,
Yes, sir.
Sneha, Hitesh, Vivek, and Yuvraj. I can say that now. Now, if I can,
Yes, sir.
Yes, sir.
okay. So try to understand. Try to understand. This minus of tan theta z is what? It is retardation. Yes or no? So this is my retardation at point G, and this is my retardation at point H. So here you can't say that retardation is happening. Okay, retardation means decrease in the velocity. But with decrease in the velocity, what is happening? The car is also stopping very much rapidly. So if you apply your disc brake, okay, so take an example. Take an example of two cars. One has a car, one, let's suppose I have the road. Okay, another road. So this is my 4-lane road. Okay, I am a very good designer. Okay, I have one car. I have another car. Not think it is a parrot. Okay, it's a car. BMW car of Anurag sir. Okay. Now, one car was having some kind of velocity, another car was also having similar final velocity. Here, I have one breaker. Here also I have one breaker. Here, the velocity needs to be 0. Means this particular velocity V final at this point should be equal to 0 for both of the cars. Here, in this car, I have one disc brake applied with it, and I have normal brake in this car. What is going to happen? So what will happen if this person comes at this point? He will have to apply the brakes. Brakes will be applied, and from this point, retardation is going to happen along the direction of motion, and the car will stop at this point. But for this car, sorry, try to understand. Okay, just change the example. 1 minute. This car is having normal tires. Okay, this car is having normal tires. It has disc tires. Okay, now this car B, if it is moving with velocity V, if it applies a brake at this point, at this particular point it applies the brakes, and again it will have a zero velocity at this point. Yes or no? Means suddenly from final velocity, let's suppose here was also final velocity V. So what will happen from this V to 0? It can do it in very much less time. Got it or not? How it is happening? Because there is a decrease in the acceleration. Means it is a rapid decrease in acceleration also. Got it or not? So these are the examples. Means when you have a rapid decrease in the particular acceleration, so what is happening? Retardation is also decreasing. Here retardation was much more. Okay, means try to understand. Sorry, here retardation was much more faster. Retardation was there, but here retardation is happening in a slow way. First little bit of decrease in velocity, then again decrease in velocity, then again a decrease in velocity, then again a decrease in velocity, and then suddenly zero. So what is happening over here? Means your velocity, the change of decrease in the velocity was, try to understand, here retardation was big. If I take R1 at this point, if I take R2 at this point, if I take R3 at this point, if I take R4 at this point, and if I take R5, what you observe that retardation at point 1 will be much more at greater than R2, greater than R3, greater than R4, greater than R5. Why it is happening? So try to understand. Let's suppose velocity V1 is here, velocity V2 is here, velocity V3 is here, V4 is here, V5 is here, and V6. What you will observe that this gap of velocity V2 minus V1 is going to be more than V3 minus V2 is going to be more than V4 minus V3 is going to be more than V4 minus V5 minus V4. Yes or no? Tell me. The gap of here little bit extra velocity will be there. Here little bit a smaller velocity. Again too much smaller velocity, again too much smaller velocity, and here the car will stop. Understood or not? So what is happening, if you check the gap, check the retardation gap, here it will be R1, here it will be R2, here it will be R3. What you will observe, that this change of this R3 is much more less than R2, is much more less than R1. Yes or no? Tell me. Guys, are you able to understand or not? Tell me.
Yes, sir.
Yes or no?
Yes,
Yuvraj,
sir.
Yes, yes,
Nissan,
sir.
are you able to understand or not? This perfect example of retardation. Hitesh, Sneha,
Yes.
Sanjana,
Yes, sir.
any kind, any kind of doubt? Nissan, are you able to understand or not? Ankit,
Understood, sir.
अंकित
Yes,
समझ में
sir.
आया ना? काफी अच्छा एग्जांपल है, मतलब समझो कि कार की जो वेलोसिटीज है ना, जैसे जैसे ये गैप, मतलब थोड़ा सा पहले पहले गैप में रिटार्डेशन हल्का कम रहेगा, है मतलब थोड़ा सा ज्यादा रहेगा, है ना? जैसे ही तुम ब्रेक लगाओगे, पहले ही तुम्हारी कार रुकने की कोशिश करेगी, ठीक है, तो रिटार्डेशन ज्यादा रहा। सेकंड गैप में क्या होगा, वेलोसिटी अपने आप, सिंस वेलोसिटी v2 भी बहुत कम है, सिंस दिस वेलोसिटी v2 is also less, v3 will be also very much less, so this r2 will become very much less. Yes or no? The factor, since r2 depends upon change in these velocities, so therefore these factors are going to decrease after some time. So that is why I have this kind of graph. At first initial graph, decrease in the velocity is very much big. After that, decrease in the velocities are very much less. Why? Because itself the velocities are going down. So this is a special case. Means when you apply the brake, this is an example. For a quick example, when we apply brakes, remember this. Remember that when we apply brakes, we have decrease in acceleration. We have decrease in acceleration. Sorry, decrease in retardation also. Acceleration is not present. Okay. So if someone says, if you apply brake, whether it is an increase in retardation, many people will say increase in retardation because they do not know what is retardation. They will say increase in retardation, but actually when we apply brakes, there is a decrease in the retardation. Got it or not? Okay. So it's next case we are going to study. Try to understand just opposite of this for fifth case, sixth case. Now this is a totally different thing. Now try to evaluate this, try to manipulate this. What is the meaning of this graph? Try to do it. Can you tell me anyone? Can you tell me about this graph? Mm-hmm.
Sir, means the retardation of at J is greater than retardation at I.
Retardation of J is greater than retardation of I. Yeah. So what does it mean? Uh,
Sir,
it is,
increase in retardation.
yeah, means it car is in retardation, correct? But what kind of retardation it is actually?
Sir,
Try to understand.
non-uniform.
Not, yeah, it is a non-uniform retardation. Perfect. Yuras, are you here or not?
Yes, sir.
हाँ, एक्सप्लेन करना थोड़ा बहुत, मतलब बीच में कभी पूछूंगा तो ठीक है। Means what is the point if I draw a right angle triangle over here? Let's suppose I have drawn this right angle, bigger right angle triangle. What we observe, slope at point
Sir,
I,
tan of theta is increasing.
a tan of theta is correctly increasing. Yes, the retardation is increasing. Means if I say, see, minus of tan theta at I is much more less than minus of tan theta at point Z. Now, what is the meaning of this? Means I want a practical meaning now. Means try to understand. So what is happening? If this is happening, this means what? Retardation is increasing. Retardation is increasing. If retardation is increasing, means what is happening? First you need to tell me. Second, velocity is decreasing. Velocity is decreasing. What is happening? Retardation is increasing and velocity is decreasing. Two things are opposite, very much opposite to each other. What is the meaning of this?
Sir, means when a body is having initial velocity, he tries to apply brake.
So
So
try
at
to,
that time,
yeah, tries to apply the brake. Example, main example is that when I throw a ball, try to understand. Okay, so I have this ground. Okay, I have one building over here. Right on. Okay, I have this building, perfect building over here. Okay, now from this point, let's suppose I throw one ball with initial velocity u. One person is here. So Abhinav, since Abhinav is experimentalist, so Abhinav is throwing ball with some kind of initial velocity u towards upward direction. What is going to happen at this final point, at this maximum height case, at
Sir,
this,
but in this case, acceleration is constant.
I, that is another thing. That is acceleration due to gravity. Okay,
Yes, sir.
so if I consider this h max, that's what I'm going to discuss. So here, if I consider this at this point, what is going to happen? Velocity of the particle is going to be 0.
Zero.
But if I consider the acceleration of the particle in this range, if I consider acceleration due to gravity, that is minus g, perfect. Okay, this is acting downwards. But this acceleration due to gravity minus of g, it is a kind of, if I say that this is a retardation or not, tell me yes or no. For
Yes,
this
sir.
upward velocity, this is a retardation, yes or no.
Yes,
So
sir.
you try to understand when it is going from initial velocity to its final velocity to be equal to 0, what is happening when at this first initial case, try to understand.
Its velocity is decreasing.
That try to understand means always its velocity is decreasing. This, in this case, the velocity, like if you measure the height at this h1, h2 and h3, what you guys will observe that h1 is much more greater than h2, greater than h3. It is a perfect case of retardation or not. Means in first case, retardation was very much high. So like try to understand, sorry, retardation was very much less. That's why it traveled bigger distance. Second case, H2 is like try to understand. H1 is bigger than H2. H2 is bigger than H3. That means what? Retardation in this, retardation R1 in this, retardation R2 in this, retardation R3 in this. What is going to happen? R1 is much more less as compared to R2, and it is much more less as compared to R3. Got it or not?
सर यहाँ पे लेकिन सर रिटार्डेशन तो हमेशा सर माइनस जी ही होगा ना.
नहीं. अगर हम अपवर्ड डायरेक्शन में बात करेंगे ना अभिनव, तो वो चेंज हो जाएगा. समझ में आ रहा है ना? मीन्स हम अगर पार्टिकल के बारे में बात करेंगे विद रिस्पेक्ट टू द पार्टिकल फ्रेम, इफ आई एम गोइंग टू टॉक, देन इट इज ऑलवेज डिफरेंट. गॉट इट और नॉट? सो इट्स
सर इस पे
रिलेटिव.
सर फिर इस पे इक्वेशन नहीं लगेगा, फिर जैसे वो 3 इक्वेशन तो सिर्फ कांस्टेंट एक्सेलरेशन का ही है.
वो तुम किसके रेफरेंस में बोलते हो अभिनव? वी से ना,
ग्राउंड के.
ग्राउंड के रेफरेंस में. यस और नो? आई एम टॉकिंग
यस
अबाउट द पार्टिकल रेफरेंस. Got it or not? I'm going to talk on
सर.
that. I'll include, I'll tell you what is relative acceleration. Got it or not?
यस
So what is happening? That in this case, because since the displacements travel are very much different, R1 is much more less as compared to R2 as compared to R3. You can take an example of a downward lift or upward lift also. Okay. So if you take then example of a upward lift going upwards, so what is going to happen? It is thrown with some kind of initial velocity. After that, what happens? There is a decrease in the velocities of the lift. If there is a decrease, what happens? That initially the retardation was much more as compared to the final retardation. Okay, so this is what is happening. Initially the retardation is much more less because the lift needs to go upward. Try to understand. Let's suppose if a lift is over here, it needs to reach over here first. The decrease in the velocity will be very much less over here. Decrease in the velocity will be very much less at this. Let's suppose this is R1, this is R2, and this is R3 at this final stage. So what will happen? This retardation will also decrease. First, try to, what I'm saying, retardation will also increase. First, the velocity will decrease. Like let's suppose this is V1, this is V2, this is V3, and here it is 0, V equal to 0. So initially, the velocity decrease in the velocity will be very much less. After that, there will be increase, there will be much more decrease in the velocity, and finally, it will be stopping over there. So try to understand retardation is increasing over here. Like how to say means if you want a perfect practical example, then I can say that if a body still needs to travel, what I'm saying, if a body still needs to travel and also it wants to stop after some time, then it should have a increasing retardation. Means what will happen with respect to increase in the retardation, the displacement of the body travel will increase. Got it or not? Okay. So these are the examples of increase in the retardation. When particular velocity are still in the decreasing rate, but still what will happen in first gap, the velocity decrease will be very much less. In second gap, the velocity decrease will be very much a little bit bigger. In third gap, the velocity decrease becomes very much prominent. Okay. So these are the example. Lift going upwards are these an example of increase in the retardation case. Understood or not? Tell me yes or no. Yes or no? Abhinav,
Yes.
Ankit,
Yes.
Radha, okay or not?
Yes, sir.
Sanjana, okay? Sneha, okay or not?
Yes, sir.
Hitesh, Vivek,
Yes, sir.
Viraj, okay or not? Tell me. So
Yes,
these are
sir.
the 4 to 5 different cases of graphs I have discussed, okay, based upon this velocity time graph. So mainly, uh, actually, I'll show you the most practical case, okay, where you will not have to take the diagrams. And this
Sir
is
means retardation is inversely proportional to velocity.
retardation is inversely proportional to.
Velocity, can we say like?
Yeah, no. It depends now. You have seen the different kinds of graph we have got.
Yes, sir.
And here, try to see this. A person is here, means a person is throwing the ball upwards. Okay. From this point, a ball is coming down. From this point, a ball is coming down. Now, when the ball is coming down, what do you observe over here? Try to understand. When this ball is coming down, you have a velocity 0 over here. Second thing, some increase in the velocity below. At different point, I'm measuring velocity v1, v2, v3. Now, if you check that acceleration, it is actually equal to minus of g. We write also this thing for this downward motion also acceleration is minus g. That means what? We have a retardation over here. Retardation. What is retardation? Retardation is amount of g over here. Now, if in this case, if I talk like what is the retardation? Retardation is what? Positive. Yes or no? Because it is a like tell me one thing, guys. Retardation is what? I think you guys will be able to answer it. Retardation is negative of acceleration. Acceleration was minus g in the downward motion. So this means what? Minus of minus g. So that means what? Retardation becomes positive and it is equal to g over here. That is what happens when retardation is positive and the velocity. Try to understand v1, v2, v3. What is happening? v1 is increasing, v2 is increasing, v3. Suddenly at the ground velocity becomes 0. So for this case means the decrease in velocity is also there, but also retardation is positive. How to draw that graph? The graph will remain same over here. Try to understand here retardation is positive and there is a decrease in the velocity from initial velocity is going to 0 velocity. Some final initial velocity is going to 0 velocity. So it represents both of the cases. Got it or not? Are you able to understand this perfectly now? Yes or no?
Yes, sir.
Abhinav? Ankit?
Yes, sir.
Yes, sir.
Radha?
Yes, sir.
Okay or not? Sanjana? Sneha? Hitesh and Yuvraj? Okay now?
Yes, sir. Yes, sir.
So these are the examples. Try to means you have to little bit understand about this. What is the practical implications of this thing? Okay. See these 3 to 4 guys have left already. The level of thing we are discussing. Okay. So this will be asked in JEE Advanced. Means different cases. We have discussed about all these different cases of retardation, all these cases of acceleration of velocities and all. So you have got the idea what is going to happen in the nature. Okay. So if you will be given any kind of problem, if you'll be given, if you let's suppose if someone asks you some kind of problem, just try to think what is happening, acceleration, retardation. Then you try to plot it in. First, you check whether velocity is increasing or decreasing. Okay. Second case after that, check whether velocity is increasing or decreasing uniformly or not. If it is increasing uniformly or decreasing uniformly, you have the straight line graph. Then check after that that increase or decrease in this particular velocity is which kind of thing, like whether it is happening along the direction of motion or happening opposite to the direction of motion. If it is happening along the direction of motion, it will be retardation. If it is happening opposite to the direction of motion, again it will be case of acceleration. So try to see this. Actually, if I ask you, if someone is going upwards, what he will feel that the ball is accelerating downwards. But if a person is down over here, he will say it is a retarding downwards. Got it? So these are two different cases to understand about it. Okay. So retardation is happening in this opposite direction, but actually the ball was traveling initially towards the upward direction. So retardation is in opposite direction. But if a person who is going upward, if he observes this, he will say that it is actually accelerating downwards. Got it or not? So it depends upon the observer. It depends the graphs. It depends upon the observer also. Okay. So we are going to include that, and that topic will be definitely there. That will be called as relative velocity and relative acceleration, and we are going to know on that. But till now, we'll be fixing on one, like, okay, my observer is this, and based upon this we try to calculate these things. Understood or not? Tell me yes or no,
Yes, sir.
guys. Yes or no?
Yes, sir.
Try to, like, I'll just take this example, last example. A road is there. Okay, means if a car is moving along this path, okay, okay, means this kind of car is there. It is moving along this path. Let's suppose velocity v1 is there, velocity v2 is there. After it turns back from this side, here it is velocity v2, here we have velocity v1. So try to understand, it has direction of displacement along this side. What you will observe, that v1 is greater than v2 or not? Tell me yes or no. And here v2 will be less than yeah, v2 will be less than v1, while v1 will be greater than v2. So for opposite case, it is an acceleration, yes or no? But for the person sitting in this direction, which is moving towards this side, will say that it is actually a retardation for him, yes or no? Means if the person is going, if I consider what is happening in forward direction, so you will say that retardation, okay, and that is minus of a. What is happening in opposite direction, if you ask, what is happening in opposite direction, if you ask, what you will say? You will say it is actually accelerating, yes or no? So in opposite direction, it is actually accelerating, while in like in forward direction, it is retarding. So this is going to be possible if it is happening, if the acceleration, if the retardation is forward direction, acceleration is in opposite direction. But one more important thing is there, that this increase in the acceleration is happening in the opposite direction. So I can say that acceleration is equal to minus of r over here, and that is why you will get acceleration is equal to a. So actually in both the cases there is a retardation. Here a retardation is there, here also a retardation is there, but here retardation is negative, here retardation is positive, though both are two different cases. Understood or not? Now are you able to understand? Yes or no? Here what is happening? Retardation is negative. Sorry. Oh, shit. Practical example again. Here retardation is positive. Here retardation is negative. So that is why if retardation is negative, acceleration will be positive. Understood or not? Tell me, guys. Are you able to understand this or not? Tell me, yes or no?
Yes, sir.
Yes,
Radha,
sir.
Radha, Sanjana, Sneha, Hitesh, Yuvraj, are you able to understand or not? Ankit?
Yes.
Yes, sir.
Okay. So this is the best example of it. Okay. Can I move to next point? Are you guys able to understand or not? Where you have to consider retardation as positive. In first case, in forward direction, velocity is decreasing, so retardation is positive. In second case, velocity is increasing, so retardation becomes negative. So if someone asks you draw the graph, in first case the graph will be like this. In second case the graph will be like this way. Understood or not? So that is your best example. Okay. Okay. Let us move. So now, based upon all of these, now we are considering, try to understand. Now we are going to include, till now we have talked about displacement with respect to velocity, but with respect to velocity. But we can talk about this displacement with respect to acceleration also, yes or no? Like if we, let's suppose if your displacement is there, displacement is travel in time t, then we can talk about acceleration also. How? So remember that if I have a constant velocity, guys, okay, I'll first give this example. Okay, one of the most important point. So if you have a constant velocity, what is going to happen? This implies acceleration will be 0. And you know that one equation of motion is there now. S is equal to ut plus half at square. So at that case, what is going to happen? Acceleration will be 0 and displacement traveled will be nothing but initial velocity into time t. But if I consider constant acceleration, okay, now if you have a constant acceleration, so a will be there. If a will be some kind of positive value over there. Now for that case, you can't write displacement equal to speed into time. You will have to consider the displacement is equal to ut plus half at square. Now consider if the initial velocity is 0. So displacement varies for the constant acceleration. Displacement varies as half at square. If I have acceleration as a constant term, I can write displacement is directly proportional to t square. And you know that is this form, is this particular displacement directly proportional to t square is the equation of parabola, like y directly proportional to x square. How you draw y x, you draw like this way or not? Tell me. So distance directly proportional to t square. If you have a constant acceleration graph, then I say that it is a non-uniform motion. First we say that. Why we say that? Because you are traveling unequal distances in equal interval of time. Understood or not? So what will be the graph of that? Displacement with respect to time, it will be, try to understand. So displacement time. Displacement with respect to time, if it is a constant velocity, it will be a linear graph. If it is a non-constant velocity, that non-uniform motion, where constant acceleration is present, so displacement will have a increasing graph. So this is displacement for half at square, and this is displacement for u into time t. Understood or not? Tell me, guys, are you able to understand or not?
Yes, sir.
Yes or no?
Yes, sir.
Understood? Ankit, Radha, Sanjana, Sneha, Hitesh,
Yes,
Vivek.
sir. Yes, sir.
Yes, sir.
So these are the most important thing. Okay. Now here we are going to take account of that only. So try to understand. If you have a displacement with time, okay. If you have a displacement with time, if you have a linear graph of displacement with time, what is going to happen? Velocity is constant. Okay. If velocity is constant, acceleration remains 0. Second case is what? What do you observe? Try to understand. Let's suppose if you consider at tangent at this point, then you consider tangent at this point, then you consider tangent at this point. When you have drawn the right angle triangle over here, what do you observe? That initially you have negative velocity, yes or no? Slope of displacement time graph is going to give you velocity or not? Tell me. So this slope reminds you what? That I have a negative velocity, then I have a 0 velocity. Then here, since slope becomes positive, that means what? I have a positive velocity, guys. So can I say that this is a kind of a positive acceleration? Why? Because you have a negative velocity initially, then you have a 0 velocity, then it is getting a positive velocity. Understood or not? So this is an example of positive acceleration. Got it? Second important point, I'm going to talk about this much more when I will be considering acceleration form in terms of displacement, double differentiation. Okay. So still many more things are left. Okay. Means 5 to 6 lecture are just left to talk about acceleration, velocity, and all of these things in terms of now numerical calculation. So at that time I'll make you much more understand. Okay. So try to understand at this point, if I draw the slope, it is a negative slope. First important thing, slope of xt, or slope of position time graph gives you velocity. What we observe over here at this point P, that slope of positive xt, slope of position time graph is pointing downwards. That means the velocity is negative. Here the slope of position time graph is flat. That means velocity is 0. At this point C, I have the slope of slope of displacement time graph as upward. That means what? Velocity is positive. We know now what is happening. From negative velocity I'm going to 0 velocity, then I'm going to positive velocity. That means what? Your velocity is increasing, and this increase in the velocity is called as what? Acceleration or not? Tell me. So you have a positive acceleration over here. Understood or not? Yes or no? Yes or no,
Yes, sir.
guys? Uh-huh. Understood or not? Tell me, everyone.
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay.
Yes,
Next thing,
sir.
Now, first important point after that. What is that? That if you have position time graph, and if you have a constant acceleration which is making the increase in velocity from negative velocity, then you will have a graph like this way. Okay, so this is a case of constant acceleration and where velocity is increasing. Second case I'm talking now. If you talk about this graph B, what you observe? Let's suppose I take point A, point B, point C. At point A, the tangent is in upward direction. At point B, tangent is flat. At point C, tangent is pointing downwards. Yes or no? Yes or no? So
Yes, sir.
what you observe from this, if you draw a triangle over here, okay. So what you are going to observe, that at point A, the slope is positive. At point B, slope is flat. At point C, slope is negative. So try to understand what is happening here. Decrease in the velocity is happening or not. First, I have a positive velocity. Then at point B, I have a zero velocity. Then at point C, I have a negative velocity. So displacement time graph for negative acceleration, this is called as retardation or it is called as negative acceleration. So for displacement time graph for negative acceleration will be like this way, means downward parabola. If someone asks you that xt graph, first important point, for acceleration a is equal to positive is what? It is a upward parabola, guys. Upward parabola. If someone asks you displacement time graph for acceleration negative, it is a downward parabola at that time. Downward parabola. Understood or not? Tell me, everyone. And if I ask for constant acceleration, there is no parabola. It is a straight linear graph. Understood or not? Tell me, everyone. Is it okay or not?
Yes, sir.
Okay.
Yes, sir.
Yes, sir.
So, Ankit, okay.
Yes, sir.
Radha, okay or not?
Yes, sir.
Sanjana, everything is clear or not? Tell me.
Yes, sir.
Sneha, okay.
Yes, sir.
Hitesh and Yuvraj, okay or not?
Yes, sir.
Yes, sir.
Okay. So basically, every time these all are different cases of graphs which I need to talk about that. Okay. So I think I have talked about 15 to 20 kinds of graph. Okay. Please make the notes of it. Make a A4 sheet. How to please? I'm really telling you. I'll send this PDF to you guys. But in this PDF, there are many things. Okay. So okay. Last form of graph. I have talked about this graph. Wait, means I'll talk about one more last graph. After this, that class will be over. After that, there are uniformly like all these I have told different equations of motion I'll be talking. Then non-uniform equation of motion under gravity we have to talk. Lift equation under gravity we have to talk. After that, neat and cassette table problems. Okay, see this. I have made all of these level of problems. Then J mentioned J advanced questions. I'm going to talk all of these things. Okay, see this kind of graph I'll be doing. This is perfect level 5 of J advanced. Okay, so all of these kind of graphs I'll be doing for you guys. You'll have to tell the answers of it. Okay. So numericals on acceleration and gravity, all of these, also this I have made. Okay. So basically your whole lecture plan has been made. The more time you will give, the more it will be very much okay for you guys. Okay. So look over here, last graph. Now let us consider, means I have a plant and I have a car over here. Okay. From this point, the car starts to accelerate and the observer is sitting at this point. What he is going to say that initially this car has some kind of displacement s naught or not? Tell me yes or no. After that, it has acceleration or not. So after this means all of this displacement s will be traveled as ut plus half at square or not? Tell me yes or no. Where initial velocity will be the particle's velocity at this point. Hmm? So that means what? If you have initial displacement, after that you are doing some displacement, what will be the total equation of displacement? Displacement will be S naught plus S, which will be S naught plus UT plus half AT square. If someone asks you what will be the graph of that, so if you have a displacement, if I have a time, so how to draw that? I'll have, since I have an initial displacement at t is equal to 0, since after that I'm accelerating, so I'll have an upward parabola on the y-axis little bit. The parabola will be shifted on the displacement axis over here. Understood or not? Means there will be little bit of initial displacement over here. After that, since you are accelerating, so you have an upward parabola graph. So therefore, total graph will be like this way. If you have a displacement and time, your graph starts from S0 over here. Means at this point it will start and it will rise up. Understood or not? Yes or no?
Yes, sir.
Okay now. So all of these things, I think now you are perfect in graph. We'll solve the numericals and based upon that, you'll be definitely able to solve it. Okay. So tomorrow we'll be solving numericals based upon the graphs. Okay. So be present. Okay. And try to understand this. Okay. Is it okay or not? Any kind of doubt till now? I'll stop the recording.